Okay, this is what's known as a goat grazing problem. All right, it's a remarkably tough problem. And I do wonder if you're interested in it, just, after I present it, I would look around the web and look at it. I want to say it has occupied a lot of people. And what occupied them was a solution to an equation. And we can do it, we can get an approximate for it, and that's the point of this section over here. But someone recently has actually come up with a closed form solution to the problem, which is kind of interesting, right? I also want to say that the United States military often gives this problem to students. Basically, I'm going to say basically to sift out the bright from the dull, all right? Now, granted, when they present it to students, what they do is present a verbal problem. And again, you may want to look into that. The verbal problem, it's really old. It's over 100 years old, as far as I know anyway. It's a problem that was presented in recreational mathematics that was, trivial. When I say trivial, it doesn't require much beyond a high school education to understand the question and to formulate this equation over here. We'll get to that. But right now what I want to point out is how I would solve this thing using Newton's method. And I want to go through that with you, because that's what the instruction is. Use Newton's method to solve that. Then we'll talk about where the formula comes from. I think, solving the equation using Newton's method is far less interesting than actually deriving that equation. But we'll get there, and we'll talk about the problem too. All right, first thing to do is I'm using Sage, by the way, define the variable, define the function. What did I do? I basically took this problem over here, and I solved it for 0, and then I simply said f of r. And when you solve that for 0, you get pi over 2, minus these things over here. And that's all I did over here. I basically just typed it in. And then I typed in, basically Newton's formula, which is, I'm writing it down as a function, by the way, that n stands for Newton, by the way, is a function of r. What is it? R minus the function divided by the derivative of the function. When I say derivative function with respect to r. And then what I do is take an initial guess. My initial guess was 1. By the way, I'm using dot n notation. The reason for that, I wanted to return back to me a numerical approximation. But it does. It does it pretty quickly. And then I keep repeating it. And why do I keep repeating it? I keep repeating it to see if there's a change. And I want to point out there is a change. The first one was 1.16, now I get 1.15. Now if you look at this one over here, it changed again, but it's far more precise. Did it change again? Yes, it changed again. Now once I get over here, and the machine's doing all the work for me, it didn't change over here. So I'm going to say within the precision of the machine at this point, this is my solution over here. What solution for? It's a solution to this equation, and I found r. Right? I actually found it. How to do that using Newton's method. And this is the r I found. R is equal to that number. Now when I say that, it's approximately equal to that number. And this is what we want to go back and talk about, the guy that actually got a close form of it, he found the exact solution to the problem. All right? Exact solution. It required something well beyond the skill set, my own skill set, and well beyond the skill set of this level of class, by the way. But anyway, not bad. I also want to point out, I use Sage, not using Newton's method. I just said, Sage, could you find the root of that function between 1 and 2? And Sage returned this over here. It's a little more precise than my Newton's method technique. Not much, by the way, all right? Now, what I want to do is basically, trying to solve this thing for R. It's not easy. I mean, we just went through that. It's numerical for us. I use Newton's method, and again, if you're finding that difficult, if you have time on the computers, it's still not easy for you, all right? But I want to point out the real issue of this problem is not solving that equation. It's getting the equation, all right? So what I want to do is talk about when I observe people solve the problem, and I have observed several people already solving this problem, presented it. A couple things I want to point out. One is they're very good at articulating and entertaining. There's no doubt about it. But one thing they often do is they give very bad pictures or trivial pictures, and I'm going to provide what I believe to be a better picture. And I'm not going to just say, oh, that's easy, you can do that on your own. And the first thing I want to point out was the first guy I witnessed to this problem indicated that this was, simple to get at but boring. And by the way, I don't see it at all being simple, and I don't see it all being boring. But what I want to do is I want to talk about the verbal part of the problem, and then we'll get to this, all right? So what I want to talk about, there's a field of grass here. It's circular in nature. All right, I'm going to shade that in. It's all grass over here. This is grass. Well, that's a lot of shading, isn't it? That's a big field of grass. Have you ever seen grass, it grows. And what you typically do with grass, you got to mow it. And interestingly, nowadays, what they're doing is using animals to graze it and to maintain it. Like, for example, go to California, you'll see them use a whole bunch of goats to graze land to clean it up, to mitigate the fire danger. But what they do now is they take a goat and they tether the goat here. All right, and then they put him on a leash. And the leash they put him on is a leash of length R. All right. Now, I hope you realize if he's on a leash of a length R, I'm going to do this over here. I'll be erasing this stuff later, by the way. I'm going to say it's R. The goat is free to roam around, and if it were roaming around, what it would do, it would consume, and I mean they're voracious eaters, by the way, they would consume all this area over here. All right. So that's important. You realize that the goat's going to consume all that on the leash, by the way. It might take them some time to do that, but they'll consume all that material. All right. I'm going to get my eraser out and start talking about what this looks like to me as far as an analysis problem where I get numbers and stuff and letters. All right. So the first thing I want to talk about is this blue circle over here. I'm going to say the blue circle has radius R. So this circle over here has a radius. That's a radius. Now, looking at my radius, just looking at the picture, it's certainly greater than 1. I can see that. Now, the green circle has radius 1. Let me go back to the green ink. The green circle has radius equal to 1. Right? That's certainly known. Now, all I know about the blue circle, radius is bigger than 1. But what I'm looking at, and I want to go through this, carefully. I want to derive some information from this picture over here. And as I do that, I'm going to label this thing over here as being the angle theta. All right. Again, just basic high school trigonometry at this point. And this distance over here is 1 unit. All right. And again, I'm looking at that green circle. This distance over here is 1 unit. And this distance over here, well, that's the blue circle, right? I'm going to say it's R units. Right? I'm going to start to erase, things I've talked about. The green circle's radius is 1, and the blue circle's radius is just R. So I'm looking at that, and what I want to do is I want to write down the other angles I'm looking at. And this is an isosceles triangle, so I know this angle over here is theta. Whoops, sorry about that. I know this angle over here is theta. Again, I'm looking at my triangle, and I'm going to call this thing alpha over here because I don't know what it is, all right? But what I do know, it's a triangle, and I know the sum of those 3 interior angles, which would be theta plus alpha would equal pi. All right, that's one thing I do know. Now, certainly looking at it, I'm going to say alpha equals pi minus 2 theta. Again, I don't think that's a stretch of anyone's imagination or they would find that terribly difficult to do. All right? What I want to do is I want to use the law of sines now. And I'll write it down. And what do I got? I have sine of theta Let's take a look at that. Again, I'm looking at the triangle. This is the triangle I'm looking at. The sine of theta over 1 is equal to the sine of alpha over r. All right? So I'm going to try to figure this out. I got a lot of letters here, don't I? So let's write this down. So I got r sine theta equals sine of alpha. Again, I don't think that's a stretch of imagination to go from here to there. All right, so I'm going to say, what's alpha? I got that too, right? So what you get? You get r sine theta equals sine. Now, alpha is just pi minus 2 theta. All right, let's keep going. Looks like it's getting complicated. But again, I'm just using what I learned in basic trigonometry. And I'm going to write this down. So it's going to be sine, it's a sum formula or a difference formula, pi cosine 2 theta minus the sine of 2 theta times the cosine of pi. Again, let's write this down. R sine theta. Well, the right side, sine of pi is 0. And the cosine of pi is -1, so I get this over here. And by the way, things are starting to shape up. I still have some trouble still. And what I want to do is write it down a little bit simpler. So we get R sine theta equals 2 sine theta cosine theta. All right? Now what's nice about this problem, I certainly know there's an angle over there, and I know the sine of that angle is not 0, so I can divide both sides by sine theta. So I get something pretty interesting. I get R equals 2 cosine theta. And I'm going to say R divided by 2 is cosine theta. And now I can tell you what theta is, at least abstractly. Theta is going to be the arc cosine of R over 2. All right, I want to go back and I want to tell you where that's written. And this is where one of the guys presenting it said, oh, that was really, just involved sines and cosines, and basically said, yeah, it's there. And almost as if it was obvious. I didn't see that as being obvious, to be honest with you, so I worked toward it. Now, if it's obvious to you, it's obvious to you. It's not obvious to me. I'm going to claim that this thing's important, though, that theta equals the arc cosine of R over 2. Again, we did that over here, all right? I'm done with that, all right? Now, again, we're going to go back over the story again. I'm going to start to erase this over here. This is important, but we got there, and we're probably going to have to use that at some point. All right? We're probably going to have to use this at some point. Okay. All right, back to my picture. It's a good picture, machine droid. I want to talk about their objective over here, though. All right, this goat's grazing, and they want the goat to eat half the field. Remember, the field is that green part. So what's the area of the field? The area of the field, right, so radius 1 circle. So the area of that field, the area of the green field, right, the green field is going to be what? Pi r squared. What's the radius of that field? It's 1, so it's going to be pi. That's the area of the green field. But I just want half of it. So I wanted to communicate to you again that what we want the goat to eat is half of the field. So we want that area here. We want this area here, area, to be half that field, which would be pi over 2. All right? And this is the problem. We have to do that now. All right? Now, let me get back to my, my picture again. I'm going to start we know what we have to do, by the way. I notice a good deal of symmetry over here. I'm going to repeat this. This area that we're looking at, that's the area that goats in. He's in a field, by the way. By the way, field has a fence around it, so it's not leaving that field. It's tethered to the edge of it. We want to eat that part, and that part of the field is pi over 2. However, when I do my analysis, I'm just going to talk about the upper half of it. And what's the upper half work? This thing over here, pi over 4. All right? So I'm just going to try to figure that out. And someone says, what are you trying to figure out? I want to know what R is. R of what? R of the blue circle. I don't know what that is. That's the leash length of the goat. Goat has a leash length on it. All right? So what I'm going to do over here is kind of divide it into pieces. Let me get my eraser out. I'm going to take the area. I'm going to do the area in pieces now. I want to do this piece over here. I hope you remember, we called this angle theta. That's from the picture before we did. So I want to do this little tiny area over here. And what's it going to be? Area of a sector. Well, the area of the sector is going to be 1/2 theta r squared. All right? What's that going to give me this thing over here? By the way, I want this to equal pi over 4. However, there's something else there, and I got to get that now. Let me erase this over here. All right? This is alpha. So what I need to do is I need to get this little section over here. I didn't get that yet. Again, this part here is this part over here. All right? But I need to get this thing over here now to fill it up completely. All right, let me erase. And let's start talking about that. Well, what I'm going to say is I'm going to look at the area of the sector. Well, that's a little bit of an overcount, but I can do that. So the area of that sector would be, what would it be? It would be 1/2 alpha times, and again, we're doing this over here now. What's the R there? It's 1. So it's going to be 1 squared. All right? But what I have to do, though, is I got to take away the triangle. Let me see if I can do that now. I'm going to erase this over here. And we're going to talk about the triangle now. I need to remove the triangle from it. This is 1. This is 1. This is R. And this is going to be the alpha over here. All right? So let's take a look at that. It looks tough, doesn't it? But I know the area of a triangle. And I got to remove it. So it's going to be 1/2. Well, I'm going to take the R to be the base of it. And now I get the height of it. All right, so I'm gonna kind of like move this thing around here. This is R. That's 1. That's 1. And the height of it is this over here. All right, I got to figure that out. So I'm going to just, in little tiny pieces, by the way. So this is going to be R over 2. This is 1. This is H. I can use Pythagorean theorem. What do you get? 1 squared, which is 1, equals H squared plus R over 2 squared. So you would get 1 minus R over 2 squared equals H squared, where H would equal, and remember it's a physical dimension, the root of 1 minus R over 2 squared. All right? So I get, I kind of get my eraser because I don't think I can fit it in there. All right? So let's write this down. Plus, and then I get to take away that triangle. What's triangle going to be? 1/2 the base, that's R, times the height of it, which would be this over here. 1 minus R over 2 squared. All right? I'm going to get my eraser out, kind of erase things, and this is going to be the area. And what's the area of that going to be? Pi over 4. I'm going to clean it up a little bit, and then we're going to go back to the notes and see if we can see that in the notes. All right? So let's write this down. So pi over 4 equals 1/2 theta R squared plus 1/2 alpha. I'm not going to put the 1, maybe I should put, no, I'm not going to put the 1 squared down, minus 1/2 of an R, and then a root 1 minus R over 2 squared. By the way, there's 3 unknowns in that problem now. Before I do anything, though, I want to go back and I want to see if I'm looking at that. All right, I want to see if I'm looking at that. In other words, pi over 4, oops, sorry about that. I do see that. I see the 1/2. I see the theta R squared. Let's see if I see this, 1/2 alpha. I didn't put the 1 squared down, but that's still 1. Minus 1/2 R, and I got this part down. And this is good news, by the way. So I am now ready to plow forward and try to get the formula. All right, let me erase all of my chicken scratch over here. I'm done with this. And now we're going to try to work our way forward to see if we can get the equation that was presented in the original part. And again, going back to the U.S. military, they give this to soldiers to see if they can work through the problem. I'm not sure exactly what they give them, other than the fact they probably give them the story. Probably just a really hokey looking picture, and this is a more accurately drawn picture, by the way. All right, so let's take a look. And what I want to do is I want to, sort of like look through it one step at a time. And, I might have to go back and review. Like I'm looking at this and wonder how they got that formula. And someone says, what formula are you talking about? The formula that was given to you. This formula. I don't see it. I just don't see it. I see part of it, but I don't see it. What I do know, though, is I know a couple things. I know this. And the other thing I know is I know alpha is equal to pi minus 2 theta. All right? So I know these things, and these are important things to know, because I'm going to use these things to get into one letter. All right, let's go for it. So the first thing I would do, right, is I want to get rid of the alpha. And let me show you where that alpha is. And I want to remember the alpha was equal to pi minus 2 theta. Again, that's written down for you. It's right over here. All right? So that's what I did. I plugged it in. So I took that alpha and just plugged it in. It's pi minus 2 theta. All right? And then next thing I did was I just, distributed property of multiplication. So what are you going to get? Let's take a look at it. R squared over 2 times theta. 1/2 times pi is pi over 2. 1/2 times minus 2 theta is minus theta. And then this thing's just left over. All right? We'll talk about him later. All right, let's keep going. The next thing I did was I combined my thetas together. Let me put that on the side for you. So I have r squared over 2 theta minus theta. And what I did was I factored out theta over 2. That may seem strange to you. You would get r squared minus 2. Let me just check that. You would get r squared theta over 2. Yep, that looks good. And then you get minus theta. Yeah, it looks good. So that's where this is coming from over here. Whoops. Did it again, didn't I? Again, theta times r squared minus 2 over 2. Right? And then someone says, what happened? I took pi over 2 and subtracted it from pi over 4. Well, if you took pi over 4 and subtracted pi over 2, you would get minus pi over 4. All right? So things are kind of coalescing. I'm moving forward at least. And I want to keep going. And where am I now? I'll point out where I am. I'm here. I'm following along each step. And I'm here. And what do I do there? I'm going to multiply both sides by minus 2. Well, if you do the left side by minus 2, what would you get? You would get pi over 2. Now, if you did the right side by minus 2, I notice the first thing I would get is, minus 2 times this term over here. The 2 would cancel off. You would get theta. It would be minus. And then what I would do is I'm going to say minus 1 times r squared minus 2, which is 2 minus r squared. That's done. That's done. Now let's do the other one. The other one's going to be plus. Well, the 2 would cancel. So you get r. And then you get the root of 1 minus r over 2 squared. All right? Let's see if that's written down. I'm going to get my eraser out. I'm done multiplying. Let's see if I get the next line, what they say I should get anyway. Did I get pi over 2? Yes. Did I get this? Yep. Different order, by the way, but it's commutative, multiplication commutative, and I got this over here. Then what did I do? Well, for the last thing, what I did was I had to remember what theta was. So I want to go back to that, and I know what theta is. What is it going to be? It's this thing over here. It's arc cosine of r over 2. So the only thing I did was I took that theta, and I put in the arc sine of r over 2. Now the big question is this here what I want it to be? Again, let's go back. I got the pi over 2. I'm going to get my eraser out. Make sure you know what I'm doing over here. I got the pi over 2. I want to see if I have this term over here, which is r times the root of 1 minus, let's see if I got that. Yeah, I got it right here. And then I get this term, plus 2 minus r squared times the arc cosine. Yes, this is good, all right? Okay, I'll repeat the problem to you. There's a fenced field, that's the green thing, that has an area of pi. They're going to tether a goat. They're going to tether the goat here on a leash of radius r. That's r. And then the goat's going to graze that field. It's going to eat all that up. And it's going to be half of the field. Your goal is to find the r. And the r, looking at the picture, is greater than 1. Right? If you were to make a guess at it, I don't know, your guess would be 1 point something, of course. But the bottom line is, you got to find the r where they'd be able to cover here pi over 2. And that's what our thing led to. Our analysis led to that formula over there. Okay, once you get here, though, getting a solution over here is Newton's method. Were we able to find the length of the leash? We were. The length of the leash, or the radius of that circle, the bigger circle, is this number over here. And again, it's pretty precise, by the way. Is there an exact answer to this? Surprisingly, there is. And again, I want to just go back and briefly talk about, people have been working on this problem. I'm going to say this problem is certainly more than 100 years old. It's part of popular culture. What does that mean? I believe it occurred in a woman's magazine, and back over 100 years ago, for like entertaining mathematics. All right, what were the readers supposed to do? I'm not going to say it's the same exact problem. It's a similar problem. They were expected to get a formula, and then I'm not sure how they would solve it back then, because Newton's method is not the easiest thing to do. There might have been other techniques, by the way, including guess and stab at it, so to speak, and use tables to figure it out. But anyway, most recently, this guy over here, the German guy, was actually to find a closed form solution to the problem. That is an exact answer to it, not an approximation, not using Newton's method. And it's a cosine of a ratio of 2 contour integrals which involve complex numbers. Not easy, super, in my opinion, super difficult to work through, all right? It was an achievement, by the way. His name is certainly known in mathematics now. Thank you for paying attention.